It's just got a special bit of middleware that allows it to serve that Blazor app for us. And then finally, we have a shared project, and that's just a .NET Standard class library. And it's one of the great things about using Blazor if you're using CSharp on your back end, that you can share your models between your front and your back end, and no longer are you having to keep things like TypeScript models in sync with CSharp models and things like that. So in terms of the client project, I've done a little bit of fiddling with this because I don't really like the standard layout that comes with the Blazor template. So I much prefer feature folders for organizing client-side applications. I've done most of my career, I've done UI sort of development and things like that. And this is a much better way of organizing stuff. I don't know if anyone's ever done an MVC app where things have been split by type, where you have controllers, views, and models. I've worked on one of those with 300 controllers. That's a fun folder structure to navigate. So these work a lot better. And the idea behind this is that we're just going to put everything that's related to a particular feature in a folder, and then you just go there to make your changes, okay? And that could be, in this case, it's a component, but it could have, I could have my styling in there because if I've got some SAS files, that could be in there. I could have some C# classes. I could have other subcomponents, things like that. So it does work quite well. The other thing I'll point out here is page components, which Mark touched on. I like to stick the name page at the end of these, just to make them a bit easier to find in that structure. There's no other way to know that a component is a page component in Blazor because you have to open it to see if it has that page directive in it. So this just saves you having to sort of open up files to find out which one if you're not overly familiar. So just a little bit about how this application is structured. Cool. So what I'm going to do now is I'm going to open up this new repair page, okay? And we're going to start working on this. So what we want to do is we want to actually be able to input some data here. So we want to be able to record a new repair. So what I'm going to do is I'm going to pop some code in, and I'm going to talk to you a bit about what this is doing. So I've just pasted in a normal HTML form here. So that's fine. I can save that and I can rebuild this. And I apologize now. You're going to be watching me doing a lot of rebuilds because unfortunately hot reloading isn't actually available in Blazor WebAssembly right now. So if I go back to the new repair page and refresh this, we've now got a nice form rendered, which is great. The only problem is now, if I submit this form, I'm going to get an error. So I'll do that, it'll blow up. So the reason it's going to blow up is because firstly, my API is expecting some JSON. Okay, so it's in the wrong format. Secondly, another bad thing about this is it's doing a full page postback because it's an HTML form, okay, which kind of breaks our paradigm of having a SPA application. So let's see if we can make this a little better. So for starters, we need to kind of be able to work with this a bit easier in C#. So we want to kind of record the information that we're going to collect in that form. So I'm going to add in this little field, this repair model field, and this is going to store all the information that we're going to collect in that form. So if I go up here and I'm going to bind these controls now to that form, and I can do that, and you'll notice here I'm getting IntelliSense as I do this, okay? These are not magic strings. So I can bind this particular input control to the name property on that form. So that's good. So to save you having to watch me slowly type all of this stuff, I'm going to ping that in with those binds. So I've just bound all of those controls to the particular properties on that model, okay? So that's good. We're going to record that information. That's two-way binding in Blazor there. But we need to deal with the form submit event because at the moment it's doing this post action, which is no good to us. So we're going to get rid of this. And we're going to use a Blazor event called onSubmit. Okay, so this is the same as the JavaScript version, except I've stuck an @ sign in front of it. That makes it a Blazor event. But we need to tell it what to do when the form submits. So what I'm going to do is come down here to my code block, and I'm going to pop in a handler method. Okay, so this method here is just going to serialize that model to JSON. It's going to post it back to our API. If it gets a successful response, it's going to set a field saying that it's successful, and that will show us a nice, helpful success message, and it will reset the form so we can go again. So all we've got to do now is go back here, and we've just got to say on submit, call this handle form submit method. So we'll do that, we'll let that build. And hopefully I'm going to give that another refresh because that seems a little quick. And there we go. So now if I come back here, so Mr. Smith, and he's got a broken bath, which I always misspell no matter how many times I do this. Cool, number, and if I hit save, I've now saved my repair. So that's been posted up to my API, and if I go to my view repairs list, Mr. Smith and his broken bath is in that list. However, there's a rather glaring issue with this form. I can also do that, okay, and it just posts it, and now if I go to my view repairs list, I've got really rubbish data in my API, so that's naff, so we definitely want to do something better about that. So I'm going to go to the shared project now. I'm going to open up that repair model, and I'm going to update this with something called, this one, data annotations. Is everybody familiar with data annotations? Anybody not sure what it is? No? Cool. So default validation mechanism for ASP.NET Core, basically. So what I've done is decorated each one of those properties with particular validation rules that I have. So I've got required fields on everything, I've got a minimum length for issue, and I've got this really succinct, easy to understand, regular expression to make sure that my contact number is correct. So that's cool. So let's get rid of that, we'll do a build. Ooh. Let me try that again. Cool, so we refresh the form now, and if I hit save now, I'm clicking, nothing's happening. And, ooh, don't want that. If I open up DevTools here and click this button, you can actually see that we're now getting an error message back from the API. So all I've had to do is add those data annotations onto that shared class that's shared between my client and my API, and my API has automatically started validating my model that I've posted. So that's good. So our API is no longer accepting invalid values. So that's cool. But it hasn't really helped us from a user perspective. We've still got a pretty naff experience on the UI. So let's try and improve that a bit more now. So we don't need this repair model anymore. So in order to do this, I'm going to replace this form element with something that we can work with, and it's a little bit more advanced, okay? So I'm going to paste in a component that comes out of the block box with Blazor. Okay, and it's called an edit form component. So this is provided for you by the Blazor team. And it's going to help us work much easier with the validation mechanisms and stuff. The other thing I've done in this bit of code that's been put in is I've replaced all of the normal HTML controls with Blazor components. So I've got an input text now where I had an input before. I've got an input text area and input select. These are Blazor equivalents of the HTML versions. But you can see it's pretty much a like-for-like swap. So I'm still binding the particular controls to particular properties on the model, and everything else is pretty much the same. I can pass these random attributes down into my Blazor components, same way as I could with HTML. That all just works. Now, in terms of the actual edit form, we have to give it a couple of pieces of information to make it work. We, first of all, need to tell it the model that that form is responsible for, so I've passed that in there. And then the other thing is we need to tell it again what to do when we submit the form. Now, you may notice that I'm now using a slightly different event. I'm using onValidSubmit. Well, there's actually 3 events we can bind to on the edit form. We have onSubmit, onValidSubmit, and onInvalidSubmit. So onSubmit is the one where you have to do a lot of work. Okay, so that's going to call whatever method you give it, but you're responsible for validating the model, making sure you're happy with the values before you post it back to the API. Now, I'm quite lazy, and that seems like a lot of work, so I'm going to use onValidSubmit, because edit form is going to take care of that for me. Okay, it's going to validate all my model. It's only going to call my method if my model's valid. So, how does it know how to do that? So, I'm going to add in another component, data annotations validator. By just adding that single component, I've told the edit form how to validate my form. It knows, inside that component, it knows how to deal with data annotations, so it now is going to use those to validate this form. If you don't like data annotations, well, that's not a problem. Just swap that out for something else. For example, with Flagship, we use fluent validations. There's a Fluent Validations validator. You just take that line out, replace it with that, and boom, now your form is using Fluent Validations. So this plug-and-play model, you'll see it very all over the place with Blazor. Blazor is very unopinionated about how you build stuff with it. So you can literally use what you want. The last thing I'm going to do is I'm going to pop in another component called Validation Summary. I'm going to do that so it can display some error messages for us. So let's let that one go through. We'll refresh this, and hopefully we've now got some validation messages. Now you'll also notice that there are some red borders around those boxes. If I use the Blazor components that come out of the box, I get this for free. So what happens is the infrastructure puts on a class, a CSS class, onto those controls, valid, invalid, and modified. So what I've done here is I've put some styling in to say that if my inputs have a class of invalid, put a red border around them, and if I have something that is valid, put a green border around them. Okay, so it's a nice little extra you're going to get out of the box. So this is a huge improvement on what we started with. However, I'm not a fan of validation summaries. I think UX is pretty bad. I have to look at the top and then try and find a control where it is, so that's rubbish. So let's try and improve that. So we're going to get rid of this validation summary. Don't want that anymore. And what we're going to do is we're going to update this to use a slightly different component. So underneath each of those controls we had before, there's now a validation message component. And then the for parameter for that, I just tell it which particular property to show validation messages for. So now that they're in place, I'll let those go through. And this time round, if I hit save, I've now got much nicer validation messages, nice and close to my control. And just to prove that this does all still do something, we'll go for Mr. Smith. I'm going to spell this right this time for a change. Broken bath, or a plumber. Put in a contact number, hit save. The repair is now saved successfully. And if we go in there, we've still got the data in. Okay, so very quickly we've been able to go from a really basic, simple HTML form, and we've got a pretty good system going with relatively small amounts of code. Okay, so we've not had a huge amount of changes there from what was already there. We've pretty much swapped like-for-like components. We've just gone for Blazor versions instead of HTML versions. So that's all good. So that's forms and validations for us. Now, we're going to turn our attention to this dashboard page. Now we're collecting all this information about our repairs. I'm sure the management people at Blazor Repairs are gagging to have some kind of graph to talk about in their management meetings. So we're going to look at that next. So we're going to use that data from our repairs, and we're going to display information on this dashboard page. So we're going to use JavaScript Interop for this. Now, one thing I'm going to, sorry, one second. I'm going to address the elephant in the room, as it were, when it comes to Blazor. The big headline with Blazor is, oh, you can stop writing JavaScript. And yes, you can stop writing a lot of JavaScript, but you're not going to stop writing JavaScript at all. WebAssembly has a huge, huge hole in it right now. It can't manipulate the DOM. It can't talk to browser APIs. Fairly significant limitation, okay? So we still have to rely on JavaScript to do that. So there's certain scenarios where you're going to have to use JavaScript for that. But more importantly, there is a huge ecosystem of libraries in JavaScript that are very good, very battle-tested, okay? And you don't really want to have to go and write all those from scratch in CSharp. They'll come along in time, and there's already component vendors writing things. There's open source people writing stuff. But, we want to get going now, and we want to get going quickly. So charts are a great example of that. There's loads of great chart libraries in JS. So we're going to use one of those to render the chart. And what I'm going to do is I'm going to show you how you can do this with Blazor and how you can actually wrap that into a component so that really, once you've done that, you can effectively deal with it in C# with C# APIs, and to a large degree, you can forget it's actually running JavaScript under the hood. So let's have a look at how we're going to do that. So in this www root folder, I've got a JS folder, and I've got chart.min.js. So this is the chart.js library, okay, which is a fairly popular chart.js library, charting library in the JS world. So I'm going to start off by adding another JavaScript file. And I'm like, 20 minutes into a Blazor talk and I've already got 2 JavaScript files. So we're going to call, so we're going to call this one chart. Oh, that's not a JavaScript file. Hold on, let me try that again. I had to swap laptops this morning, and weirdly enough, this keyboard's a bit odd. Cool, there we go. So let me just scroll this down a little bit, and I'm going to pop in some code into there. So I'm going to shrink a lot of these bits down, because to be honest with you, you don't need to care about them. They're all boilerplate. So a couple of things to note here. Firstly, I've created an object on the window called Blazor repairs, okay? So the JavaScript APIs in Blazor are all relative to the global scope. So you have to have something on the window object in order to get to it from Blazor. Now, inside of that Blazor repairs object, I've got a simple function called build chart that takes an element reference. Now, I've scoped it this way on purpose because I could have just put this build chart function directly onto the window object, but then if someone else's library puts another function called build chart on the window object, then we're going to have issues. So this is effectively like namespacing in CSharp to a degree. So that's why I've done it that way. And then inside of that, this is largely boilerplate code. I'll be honest, I've copied and pasted this from the Chart.js Getting Started guide. And all we're doing here is creating a new chart, and that's going to render in whatever element we give it. So we've done that, and now I'm going to reference both of these JavaScript files in my index.html. So let me go there. I'll pop in those links. So now we're going to start working with this in Blazor. So we're going to show this in the dashboard. So I'm going into my dashboard feature here to do this. And I'm going to add a new component in here. So this is a razor component. And we're going to call it chart. I'll pop in some code there. So what I've pasted in here is, at the start, I've got a normal HTML canvas element. And then I'm capturing a reference to that HTML element using Blazor's ref directive. Okay? And I'm storing that in that private field chart container, and I'm using this element reference type, which is provided by Blazor out of the box, specifically to capture relevant references to HTML elements. The next thing I'm doing is I'm overriding one of the Blazor components lifecycle methods. So we have 3 of those in Blazor. We have onInitialized, onParameterSet, and onAfterRender, and they all have async equivalents. So onInitialized runs once in the lifetime of a component. OnParameterSet runs every single time an incoming parameter to the component changes, so you can do any logic there based on that. And the final one is this onAfterRender. Now, this is the one where you always do your JavaScript interop. It's technically possible to do it in others, but never ever do that. And there's 2 reasons for that. Firstly, if you're pre-rendering on the server, this method does not get called. Now, that's really important, because on the server, there's no DOM and there's no JavaScript. So what happens is you just get an unhandled exception and everything blows up. Okay? So that's one reason. The second reason is that when you're doing this in the right place, you need a DOM to actually do stuff. For example, here I'm capturing an element to capturing a reference to a DOM element. So I need a DOM in place to do this. So I need the component to have rendered, hence onAfterRender. Okay, so that's why you want to do it there. In terms of accessing JavaScript, I'm doing it using this IJS runtime that I'm injecting at the top of my component here using the inject directive. So the JS runtime is your gateway to JavaScript from CSharp. So there's 2 methods on that. There's an onInvoke async, which is when I can call into JavaScript and get a return value. And then there's this invoke void async, which, as you probably guessed, is when I'm calling into JavaScript and not expecting a return value. However, they both pretty much have the same signature. So I start off by telling it which function I want to call relative to that window object. And then after that, it's just a parameters array, so I can just pass as many parameters down into JavaScript as I want. And in this instance, I'm just passing down the reference to our canvas element. So we've got that there now. If I go to my dashboard, the last thing I need to do is put this new chart component to the test. So we'll pop that in, and I'm going to do a build. There we go. Aha. So, good news for me, it's worked. So, I've now got a chart.js chart rendering with relatively little effort. Okay, so I've now got that nice library working for me, and it's taken me a couple of minutes to get going with it, which is pretty cool, and I've got all the functionality that comes with it. However, the data is a bit rubbish. Okay, this is some hard-coded data that I've got from their Getting Started guide. So now let's start, creating a nice API for this so we can work with this longer term in C#. Yeah. Yeah, that's fine. Yeah, you can do that. Right, cool. So we'll jump back over to the code and let's start improving this a bit now. So this chart wrapper, for instance, let's have a look here. So we've got this hard-coded data and we've got this hard-coded type. Now, I don't want to have to come into JavaScript to change this every time I want to change my chart type and things like that. So I want to pass this information down. So I'm going to pass in a type and I'm going to pass in the data that I want to be rendered. And I'm going to replace these hard-coded values with those variables. So that becomes type. And if I come down here, I'm just going to get rid of this entire data object. And instead, I'm just going to say render whatever I pass in. Now, the great thing is now I've basically made this entirely boilerplate. In fact, I've made it so much boilerplate that I'm going to get rid of it because we never, ever need to look at that again. Okay? So that's good. That's in place. The next thing I need to do is create a nice API to work with that library and expand this component a bit. So I want whoever consumes this component to be able to pass in the type of chart they want rendered along with the data that they want rendered. So how do I do that in Blazor? Well, in Blazor, we have to specify the public APIs, and we have to use this parameter attribute in order to do that. And then after that, we just need a public property. So I'm going to say this one's a string, and this can be our type. And I'll put another one in here, and this one, and we can call this chart data, although we haven't created that type yet. And this will be our data object. Okay? So that's our public API for our component defined, so that's quite cool. But we need to represent that JavaScript data structure in C# somewhere so we can work with that. So let's do that next. So I'm going to add a normal class, and we'll call that chart data. Cool. So again, you don't really need to care about this that much, but just trust me, this is a C# representation of that JavaScript data object, okay? There's nothing particularly exciting about this, so it's just there to obviously glue everything together. So that's cool, we've now got this chart data type there. So this is good. I think the last thing that's left for us to do here is we need to pass down that type that we had and data. We need to pass that down as well. So that's pretty much done now. We can pretty much get rid of this component as well. We don't really need to look at that anymore. We've defined our API. It's dealing with JavaScript. Cool. We'll leave that over there and working. So the last thing I'm going to do is I'm going to update the dashboard page now to actually make use of that. So let's pop that code in. So there's a bit more code here now, but you can see straight away there's that updated chart component with our API we just defined. So we can pass in the data object that we want rendered, and we can say that the type of chart we want is a bar chart. So we've got to do a little bit more work in this component now. So I'm overriding on initialize, so that other lifecycle method I talked about a second ago, and I'm using that to call my API and get my repairs data. And then I'm passing that data into this private method, create chart data, and in there, all that does is construct that data object using that C# class I just created. Okay? So again, there's nothing overly technical and overly difficult about that. And that all gets passed down. So we can do that, and we can do another build. Cool. So now we've got our chart rendering with our custom data. Okay, so we can now see our completed repairs versus our outstanding repairs. So that's good. That should keep management busy talking about that. And we get nice tooltips and all that. So we're getting all that functionality from chart.js, but we've had to do very, very little extra work. And that little bit of work we have to has allowed us now to kind of forget that we're actually using chart.js under the hood, because we only have to deal with this component going forward. If I want to put a chart somewhere else, well, that's not a problem. I'll just use my chart component. I don't care that it's running JavaScript, okay? And this is evident now because I can come in here and go, actually, no, you know what? I would rather see a pie chart because that's a nicer thing, and I like pies, so it's all good. So I can change that to pie. I'll do another rebuild and run this, and now I get a nice pie chart rendering, okay? So while, yes, I'm still using JavaScript, okay, I don't really have to care about it as a developer anymore, okay? I can just leave that in a box. And when WebAssembly does get the ability to manipulate the DOM, which it will do, I can just refactor this, and I haven't got to change all my consuming code anymore. It's all encapsulated in that one component. So this is looking pretty cool now. So we've got a nice dashboard. We've got an ability to add our new repairs, and if we go in our view repairs, we can list them all out. So this is all good. But I know that probably GDPR people would be going nuts right now because there's literally no way of securing this data. We've got all these contact numbers and names and things, so they're probably doing Fruit Loops now. So we should move on to authentication and authorization and look at how we can make this app a bit more secure. So let's go over to our code. Now, the first thing that we're going to do here is we're going to go to the server project, okay? And we're going to open up our API controller, our repairs API controller, and I'm going to stick an authorize attribute on this, okay? I'm doing that first, very importantly, because the number one place you secure before you do anything else is your server. Because however nice Blazor is and however fun it is to enjoy CSharp in the browser and all that, well, you can't trust it. Okay, it's a client application, it's running on the client machine, they can decompile your DLLs, they can reverse engineer stuff and whatever else, okay? So whatever we do in Blazor is cosmetic. What we're going to do in Blazor is we're going to try and basically give the 99% of users who are going to try and use our app the right way, the best user experience possible. But ultimately, security is about the server, okay? So that's the first thing I've done. So now I've done that, if I come back over here now and I try to load up my repairs, I'm not getting anything. If I go into the dev tools, you can see I'm getting a 401 not authorized. So that's cool. We've done, step one of security and made our server secure. So that's a good starting point. Now, just for reference, this API is secured using JSON Web Tokens. So it's just some hand-rolled stuff for now, just for the sake of a demo. But normally, you'd use something more robust. You'd use an identity server. You'd use something like Azure AD B2C or Auth0 or some other thing like that. You would hopefully not be doing it yourself because this thing's really complicated and it's far best left to experts. But for the sake of this demo, it just shows how we can work with JSON Web Tokens, which are pretty much de facto way of doing client-side applications. So that's what's going on there, so I'll get rid of that. So we've secured our server now, so let's start turning our attention to our Blazor app. So what I'm going to do is I'm going to open up each of the pages in here, and I'm going to pop in an attribute. I'm going to use that same authorize attribute that I just used on the API. This is because Blazor is built on the same security infrastructure as the rest of ASP.NET Core. So that authorize attribute is exactly the same one that I just applied to my server controller. And I'm using the attribute directive to do that. So I'm going to stick it on, we've got it on the dashboard page. I'm going to do the same thing on the new repairs page down here. And I'm going to do the same thing on the view repair page as well. Okay, so we've added those in, which is great. Now, that actually isn't going to do anything for us, okay? And the reason it's not going to do anything for us is because Blazor doesn't really know what authorized actually means. We've got to tell it, okay? So the reason we have to tell it is because there are lots of different ways you could work out how someone is authorized, okay? You could be using Identity Server, you could be using Azure B2C, you could be using the ASP.NET Identity Membership System. You could be using some completely handcrafted, hand-rolled, bespoke solution that your company has developed, okay? So there's no real way to know this out of the box. So we're going to provide an implementation of something called an authorization state. Oh, excuse me. So let's go over and look at doing that. So if I come back up here, Go add a new folder into the project. At the top level, I'm going to call this providers. I'm going to create a new class now. Called a token authentication state provider. Okay, now in here, I'm going to plop in a load of code because as you can see, my typing is slow as hell. Cool. So let's walk through this now. So out of the box, Blazor provides this class called Authentication State Provider. Now, it doesn't actually do anything. All of the Blazor components have this injected into them when they need to care about auth, but there's actually no implementation in there. The only thing that's in there is an abstract method, this getAuthenticationStateAsync, and we have to provide an implementation of that. Now, what's going to happen is all of Blazor's components that care about auth are going to call this method, and they're going to use that to determine whether we're authorized or not. So we need to tell it what that means. So as I said, this is using JSON Web Tokens. Does everybody know what JSON Web Tokens are before I go any further? Yeah? Okay, cool. So what's going to happen is when we log in, and that's successful, the API is going to return us a JSON Web Token, and we're going to save that, and then we're going to include that in every subsequent request we make to the API. So the starting point to work out whether we are authenticated is to check if we have a token in local storage. Okay, so that's what that first line's doing. It's trying to get that out of local storage. The next thing is I'm constructing a claims identity based on the values in that token. Now, if that token doesn't exist, I'm going to create an empty claims identity. If it does exist, then it will create an identity based on what's in that token. The next little block here, that's attaching that token as an authorization header on the HTTP client. Again, if I haven't got a token, it won't attach one. It'll get rid of one if it's already there, in fact. And then the final bit down the bottom here is I return a new authentication state. And in there, I generate a new claims principal based on that identity. Okay? Now, if my identity is empty, then that's equivalent to saying that I'm not an authorized user and I'm not going to get anywhere. Okay? If it's got an identity, then I'm going to be that person. The other two bits in this class are the login and the logout methods, okay? And they're just helper methods. So when we look at the login page in a second, you'll see that on a successful login and the token comes back, I'm going to persist that to local storage, and then I'll just call this notify authentication state change method, which is the thing that tells Blazor to re-render because something's changed in auth state, and that will all kind of magically work, as you'll see as I get going. So we've created our token authentication state provider now, so that's cool, but we need to kind of wire this up and get this working. So I'm going to go to the program file, I'm going to go to the main method. Now, this probably looks a bit odd if you've done anything with ASP.NET Core before. You'd be thinking, surely you should be going to the startup file. Well, no, because in the latest version of Blazor WebAssembly, the startup file has been binned. Now, I was curious about this, and luckily I was at NDC at the time, so I talked to Ryan Nowak, who's the chief architect with Blazor, or one of the architects of Blazor, and he was explaining to me that the reason they've ditched it is because it actually doesn't make sense in Blazor WebAssembly. Now, there's two methods in the startup class. There's a configure services method, which is where you can add all your services to the DI container. Now, that's fine. There's no issues there. The big problem, though, is the other one, the configure method. This is where you configure your middleware pipeline, okay? But there's no middleware in Blazor, because there's no request in Blazor, because actually Blazor is the equivalent of a desktop app in terms of how it runs, okay? You boot it up, it loads up in your browser, and it exists for the lifetime of your tab. It's very similar to open up a desktop app in that you click around and use it, and then you close it when you're finished, okay? You're not going off to the server, it takes that request, it goes off and does something, and then it returns you back some HTML like it does for, say, Razor pages. Okay? So middleware has no place in Blazor. And weirdly enough, people had tried to write middleware. Okay? So from his point of view as a language designer, that's not great. Okay? It's conveying the wrong message. So I decided to get rid of it. It just wasn't needed. So we can do our dependency injection in the program class instead. So on the builder, we can access the service collection there. So I'm going to pop in those services. I will need to just add some using statements in here as well to get this going. Lovely. So, ignore the add options. That came in as well with the latest version of Blazor, and I'm fairly certain that's a bug. I don't think that should be there. If you don't have add options in there when you use add authorization core, it throws an exception. I'm fairly certain that's a bug, so ignore that. So the add authorization core is telling Blazor that I'm going to use the authorization stuff, and again, this is all built on the same stuff from ASP.NET Core, so that just wires up those services. Then there's add Blazor local storage. That's a shameless plug from one of my libraries. Okay, so that allows you to interop with the local storage APIs in the browser really easily, and you don't have to care that that's using JavaScript. Next thing is I'm adding that token authentication state provider as a scope service, okay, and I'm adding that independently. And then I'm saying underneath, any other components that request an instance of an authentication state provider, don't give them that. Give them my token authentication state provider from your container, okay? So any of the Blazor infrastructure that requests that is going to get my implementation instead. It's then going to run my implementation of get authentication state async, and that's how everything's going to work, okay? So the final thing that I need to do here is make a little change to the router. So this is Blazor's router. It sits in the app component, which sits right at the top of the tree of your Blazor app. And this root view component here on line 3 is responsible for loading a particular page that you're trying to get to. Now, this root view component's a little dumb. It doesn't understand the authorized attribute, for example, so it's not going to check to see if I'm authorized before I do anything. So we need to replace that with something that will. So I'm going to pop in a different component called authorized root view. Now, again, this probably makes a lot of sense, but this is going to check if a component I'm trying to navigate to has got an authorized attribute, and then it's going to call that token authentication state provider, and it's going to find out if I'm authorized. And if I am, it's going to let me go there, and if I'm not, then it's going to need to do something else. So we need to tell it what to do there. So for not authorized, I'm saying show a login component instead. Okay, so if I'm not authorized, show a login screen. And you'd have seen that earlier. That's sitting here in the features folder. So I've got this login.razor file that's commented out at the moment, so I'll just bring that back in, and I'll just do a build on that, hopefully. So this has just got a simple edit form in it that takes a username and a password, and then that just posts it up to the API. And if we look at how that's handled down here, if that login result is successful, so we're successfully authenticated, we're going to persist that token, okay? And if we're not, it's going to show an error. Cool. So with all that in place, if we come back over to our app now and we do a refresh, we're now seeing a login screen, which is good news. So I can click on any of these links, I get the same login screen, because it doesn't matter where I go, I'm not authorized to see any of them. Now I can log in. I'm going to use my super secret user 1 exclamation mark. And now I'm logged in as a user. Okay, but you can see I didn't need to do any fancy redirects or anything like that. It just updated to show a authorized login. Okay, so that's Blazor doing all that diffs behind the scenes for you. So that's cool. I can now view my repairs. I can go on my new repair screen. I can view my dashboard and things. So this is all great. However, you know, not everyone in the company needs to view this repairs data like this. In fact, only people in a role of planner need to view this particular data. So let's see if we can lock this down a little bit further. So we don't need that anymore. We don't need that anymore. So what we're going to do is go over to this view repairs page. So we're going to update this now. So at the moment, we've just got this single card component that is printing out that table to show all of our repairs. So we don't want to show this to certain people. So we're going to replace that, and we're going to use a different component instead. So we're going to use the Authorized View component. Now, in this component, I can say someone needs to be authorized by not specifying anything else. That means they've just got to be logged in. But in this instance, I'm saying you have to be authorized and in a role of planner, which I've got at the top there, in order to view the authorized content. So I've got an authorized template here, and that's just the same card that I just replaced, okay? So that's going to print out that same table that we had there before. And then underneath that, I've got a not authorized template, okay, down here, and that's just going to show a nice friendly message to someone if they're not authorized. So we've got that in. Let's restart or rebuild our application again. And if I go over there now, As a user, I'm now not authorized to view this information, okay? So I'm seeing this not authorized. And again, I can still get to the other pages because there's no extra security on those, but my view repairs, I'm stuck. So that's cool. Now, the biggest problem we've got is that I've got a login as a planner. The only problem is I can't log out. There's no log out button here. So we should probably deal with that. So what we're going to do is go over to the shared features, and I'm going to go to my layout and my header bar because I'm going to want to put it there. And in there, I'm going to add a new component. Cool. So in here, I'm going to create a user status component, okay? Cool. So here I'm using the authorized view in a much more simplistic way, okay? I've not got any roles here. I've not got different templates. All I'm saying is if the user's authorized, show them what's in it. If they're not authorized, don't show them anything at all. That's how this is going to work. I'm also injecting the token authentication state provider at the top, and that's purely so in this on-click handler of this button, I can call the logout method that's going to delete the token, and then it's going to call that Blazor infrastructure to say that the authentication state has changed, and that's all going to refresh, and it's going to log me out, okay? The other thing that is quite cool about the authorized view is that we have access to this context object, okay? And then we can access information about the user. So here, for example, I'm printing out the name of the user, but I could also look at their claims, for example, and stuff like that. So that's quite cool and useful to have. Now, I need to put this user status component in the right place. So I'm going to go in my header bar. I'm going to pop that in there. So let me just build that. Cool. So now it's saying, hi user, and it's giving me a logout option, which is cool, and I can hit that, and now everything's dynamically updated, okay? So I'm now back to being a logged out user, and I'm seeing my login prompt. So I can come in here as a planner. Log in as a planner, and now I can see my view repairs data, okay? I can still go to all my other pages, because as a planner, I'm still authorized to view those, okay? So it's all up and working. So that was a very whistle-stop tour around some features of Blazor. So I hope you've found this a bit interesting and a bit enlightening. In terms of, that's not enjoying that now. There we go, let's try and get this going again. Some resources for you. So if you're getting into Blazor development, here's some stuff that I think is useful to get going. So the Blazor official site is obviously good. There's the official docs on there and things like that, so that's well worth checking out. A lot of good information. There's a repo called Awesome Blazor on GitHub that's maintained by a guy called Adrian Torres, who puts a lot of work into that. There's a phenomenal amount of content in that repo. So there's loads of stuff there, so definitely worth checking out that. There's a Gitter channel for Blazor that's incredibly active. There's people in there chatting literally all day long, so very knowledgeable people in there as well. So if you need help with Blazor, you can go there. Blazor University is a site done by someone in the community called Peter Morris, and that is, again, an absolute treasure trove of information. It's very much done in a reference style with lots of really good long explanations about how things work and why they work and things like that. And then finally, there's my blog as well, so you can check that out. I think I've got about 40 or 50 blog posts now on Blazor, so hopefully there's something useful for you there. So that's everything from me, so thank you very much for listening. I don't know if we've got a few seconds for any questions or not, but... So not now, but I think there will be. When Blazor WebAssembly goes GA in May, I believe they're doing some stuff out of the box. So instead of like that token authentication state provider that we just did manually, there will probably be one for identity server, because that tends to be the preferred auth system. There will almost definitely be one for Azure. That would obviously make sense. So I think there will be the ones that will come out of the box for sort of the better known models. But I think it's just good to know, because if you're doing anything bespoke. can we catch up with this? Like, I'll be honest, this isn't a quick conversation. I've written an OpenID Connect library for Blazor, and I can talk to you about an hour about that alone. So we'll catch up with that afterwards. That's all right. Sorry, Paul, what was that? Yeah, that's an interesting question. So what I don't have in this talk, but in my other talk, is about how Blazor's actually built. And Blazor's got a really interesting architecture. So Blazor's actually split into two halves. So there's a Blazor programming model that sits at the top, and that includes things like the renderer, the diffing algorithm, all of this kind of stuff. But it's completely ignorant of what it's rendering, okay? Because every Blazor component gets compiled to a C# class, and every piece of information in your component gets compiled to a C# instruction. Now, it doesn't matter what's in that instruction, okay? Blazor's rendering and diffing algorithm just cares that it's an instruction, okay? The actual rendering is delegated to renderers. So WebAssembly uses a WebAssembly renderer. Blazor Server uses a remote renderer. And there's also a new experimental one called Mobile Blazor Bindings Renderer. And that is where you can write the same programming model that you've seen there, okay, exactly the same style using Razor and everything like that, except instead of using HTML, you use native components. Okay? So you can write an app for iOS or Android or whatever using Blazor's programming model, and Blazor doesn't care about it. That all happens in the rendering stage. So yes, I think what we're seeing here with Blazor is the birth of the first UI framework for .NET, because it's the one bit that we've not had in .NET. It's always been back-end code. We've never had a UI framework, and I think that's what Blazor's going to be. I think Blazor will be a way of writing, you can learn that programming model once as a developer, and you can write UIs for desktop apps, for mobile apps, and for web. I think that's where it's going personally.
You see teams with lots of front-end JavaScript guys, a very good eye for style, very bad eye for types, being able to gel with this well.
Interesting. It depends how open they are to change. It's a really interesting one. I'm not of the side of the argument of, oh, let's kill JavaScript. Okay, I've worked in JavaScript for a lot of years. I like bits of how it works and things like that. I've written Angular apps for about 5 years now. I see it as a synergy. I think you can bring the two halves together. Like I say, that's why I make it a point of most talks that I do, I try and include JavaScript Interop in it, because this isn't about one killing the other. This is about, a bit like was said earlier, it's about offering options and choices. We can all exist together. You know, it's not like one's got to be better than the other. So, you know, maybe they could learn a bit of Blazor and how that works. And, you know, we've all been learning a bit of JavaScript to get by for quite a while now. With WebAssembly, the world is changing. You know, there are going to be competitors to JavaScript, and it's never had to do that before, so I understand why that's scary. But I think over time, once the trepidation calms down, people realize that their jobs aren't going to disappear overnight, things like that. I think people will be more open to the idea of trying different things. So, who knows? What do you mean in terms of what? Having that just render when that component's on the screen and get rid of it again when it goes away, or?
Well, just so it wraps it up.
Isn't that what we did with the Chart.js stuff?
So that it's not accessible without instantiation.
I don't know. Ultimately, JavaScript's got to work. It's got to be there in JavaScript. It's got to sit on that window object. It's got to be present there and things like that. So, other than the way I've shown you, I'm not sure how else you would do that. But we can talk about it after if you want to go into more detail. Anybody else? No? Cool. Done. Thank you.